100, and let's do a cosmology segment. Because here at the Smash News Network, we are interested in cosmology, as I and many others believe that it is super important to all sorts of things from climate and more. So Least Busted Name in News continues on here with today's cosmology segment. Let's talk about cosmic ray flux. As you will see at the Oulu neutron monitor, as well as Mexico City and other neutron monitors, cosmic ray flux is not as high as it was in 2010. So I brought up this chart here to intentionally cherry pick the data. This is the highest cosmic ray flux ever measured. This is not, as you can clearly see on the Oulu neutron monitor. Now, there is a disparity that happens between solar cycles, and I can't get into that in this video because it's going to appear in later content. But I brought up the graph here from 2009 to 2021 to show this obvious fact. These levels are the highest cosmic ray flux ever measured, and any YouTube channel suggesting that these are the highest levels ever measured should either watch our videos or stop lying to their viewers. Let's talk about NGC 6960, the Vale Nebula, and check out the imagery. All these filamentary areas in here, these strings of material, and it's a chemical soup, folks. It's a chemical soup. Anyway, there's an interesting article about it here on SciTechDaily.com. The spectacular return to the Vale Nebula. So some great imagery here by the Hubble Space Telescope. And again, this is including ionized oxygen, ionized hydrogen, and ionized nitrogen, shown respectively in blue for the ionized oxygen and red in the ionized nitrogen. No indication of what color the hydrogen is. I guess green? I don't know. I think it's probably the green part. I have no idea. You think they would have let us know? So this is located 2,100 light years from the Earth, 2,100 light years, and is located in the Cygnus Loop. Fantastic imagery there from Hubble on the Vale Nebula, otherwise known as NGC 6960. And I just wanted to show you this in some additional wavelengths here. So here's Finkbeiner, which is hydrogen alpha. And you can see there's lots of hydrogen in galaxies and really all around space. And check it out, some huge filaments of hydrogen associated with this area. And we're also going to show you some other wavelengths here. So here's optical, bands Z and G from Pan-STARRS. Let's center that again and zoom in. So there's a great view of the nebula as well, in just 2 optical bands, folks. And we'll also show you, let's see here, how about blue light? And you can see it is a feature-rich region of space, to say the least. NGC 6960, otherwise known as the Vale Nebula. Now let's pick a totally non-random object. Today's totally non-random object is Sagittarius A star. Now, why do we talk about Sagittarius A star? Well, it's kind of important, folks. And so here's what's going on at the core of the Milky Way galaxy. Those are all supermassive blue giant stars, which are much more massive than the Sun, and they orbit in, some of them in more circular orbits, some of them in highly eccentric orbits, as you can see this one here that's coming right to my face. Wait for it. There's that highly eccentric orbit. And so the point is, folks, what's going on at the core of the galaxy is absolutely nothing like what's going on in the solar system. These stars are orbiting the galactic core on multi-different planes, so there's no coherent galactic core disk, and the interaction between all these stars, we really have no idea what is honestly going on fully, because we're only able to see the core of the Milky Way galaxy in certain wavelengths. So in any case, this is one of the animations, and you can find lots of animations. We can't see the object around which these other objects are orbiting, but those objects are large massive stars that are orbiting like grains of sand around the massive radio source at the core of the Milky Way galaxy, known as Sagittarius A star. Now, what we normally show is just this, which is a high-resolution background of a small, tiny portion of the Milky Way galaxy. It's actually the Big Dipper that we regularly show on the channel. And so now we're going to show what goes on as far as X-ray emissions from the massive radio source at the core of the Milky Way galaxy. And there are the X-ray transient bursts. You can see here this is the approximately 16-year chart of the X-ray output of Sagittarius A star. And here's the 30-day chart. We did see a pretty strong burst here about 20 days ago. And you can see that made it all the way up to 0.17, which would be off of this chart entirely. That would be like way up here on that chart. But otherwise, it's a pretty consistent X-ray source. And if you want to look up your favorite transients yourself, head to the Neil Gorell Swift Observatory. The Neil Gorell Swift Observatory, the Burst Alert Telescope. And you can look up all your favorite objects there, perhaps. In fact, let's see if we've got NGC 6960. I think it'll probably be there, but indeed it is not. So one of the other X-ray sources you may look up is the Crab Nebula, right? The Crab Nebula is one of the most consistent and strongest X-ray sources in the entire Milky Way galaxy. And it's such a consistent source that it's actually used to calibrate equipment, like X-ray telescopes. There are the transients from Crab. Don't be a crab. And I don't know why I have a query for Sagittarius A star here. Let's close that tab entirely. And that's today's Cosmology segment. Let's continue on here at the Smash News Network with additional data.